This is a supplementary video to my dash cam installation on the Toyota 4Runner and covers the design of the mounting bracket using Autodesk Inventor. At the start of the design, I already have a general idea of what it will look like, as well as approximate dimensions. I will work out the final dimensions as I go along with the design. When the design is complete, I will prototype it on my 3D printer and then, if necessary, make any adjustments. Now, let's get started. To see the starting point, you need to click up here in the corner for the dash cam installation video to find out why I need this bracket. But here we go. Pressing the hotkeys Ctrl-N brings up the New File dialog box. And from here, we're going to start a new part. The concept of the bracket is essentially sheet metal, so the first thing I'm going to do is to convert this drawing to sheet metal. Clicking the Convert to Sheet Metal brings up the Sheet Metal Defaults dialog box. I've never set up any sheet metal rules, so I'll turn off the Use Thickness from Rule and select the material and thickness manually. And now I'm ready to create the first part of my bracket, which will be the mounting face. Now starting a new sketch, but with only a concept in my head, I'm going to Padoma all the dimensions. First drawing an unconstrained rectangle, then adding dimensions. There will also be a hole of, at this time, unknown size and location, so we'll add that here as well. Here you can see that my new rectangle can float all around the drawing canvas, which is a very, very bad idea. It is best practice to ground all new parts or assemblies to the UCS. This both stabilizes all parts and assemblies and enables the use of origin planes and axes during design and constraining in assemblies. Using the coincident constraint, I pick the center point of one of the longer edges and attach it to the center point of the UCS. Exiting the sketch and then selecting the face function, we now have the first part of our bracket. Now it is time to add a couple of flanges. I am estimating I need an offset of about 1 inch, but I am not sure what I need for the mounting of the camera, so I'm just going to make two 1-inch flanges and adjust later if needed. Select the flange function and then the edge where you want to flange, modify as needed, and click OK. Then I repeat for the other edge. A quick look around, and then I go up and reset the view cube so its default view is facing to the inside of the flanges. To continue the design, I'm going to need to put the camera in onto the flange, so next up I'm going to model the rear camera. The camera model is going to be an assembly with two parts, the camera and the mounting base. The camera model is relatively simple, where I start a new part, a new sketch, draw a circle the diameter of the camera, then extrude it to the length of the camera. Although not necessary for this design, I add a fillet to one end. Modeling the lens of the camera will be the first instance where you get to see why it is a good idea to ground parts to the UCS. The camera lens is offset slightly from the outside diameter of the housing, so I need to create a drawing plane. I create the plane referencing one of the origin planes, which is centered in the housing. The offset distance means nothing at this point. Now bringing up the parameters dialog box, the last one in the table will be the offset for that plane. Changing the equation from a static number to the diameter of the housing divided by 2 plus the length I measured for the offset, and now it is in the correct place to draw and extrude the lens. A new sketch, a circle, constraining it to the center line and 1/2 inch from the end. Extrude it using the two extents, selecting the face of the housing and then making it pretty by adding a couple of fillets. The last thing to do is to hide the plane. Select the plane in the browser window, right-click, and turn off the visibility. I thought it was a little boring leaving this just a shade of gray, so I decided to give it a little color and emphasize the lens. Going up to the Quick Access toolbar, I click on the Appearance pull-down and select a new color. And now for the lens. A new sketch on the face of the lens extrusion, and I draw an arbitrary diameter circle and exit the sketch. Now extruding that circle into the part just a bit. Select the face of that new extrusion and go back up to the Appearance pull-down, then select the color of your choice. Note that the colors in the part environment are not the same shade when put in the assembly environment, which we will soon see. For the camera base, I've entered most of the dimensions in the parameters, so we can go through and create everything on the fly. First up is modeling the base. Starting a new sketch and drawing a circle, and then just throwing in a random dimension. But going to the parameters box, and we pick the diameter. Clicking the checkbox, now we've got our diameter, and exiting the sketch, we extrude it. And again, going to the parameters, we pick length. Now it is time to build a couple of walls, so let's get the sketch started. A line along the base, going up just a little bit, and now I'm going to draw an arc up to the base. Now picking tangent, we're going to make that arc tangent to the base. And now for the length, selecting the edge and over to the far end of the base, and then back to the parameters, and we called that one the mount, or the base, I'm sorry, called that one the base. Now I know that's about 0.2 inches, so we just struck that in there as a hard dimension, but everything didn't turn dark, which means something is not constrained. Making the end of the arc vertically constrained, but we can still move things around. So we're going to throw in a tangent to the bottom line to the base. Now everything's turned dark and all constrained. Exiting the sketch, and then extruding the wall thickness. Which I called wall in the parameters. Now to make another wall, all I need to do is mirror that, but I did not extrude it correctly to allow mirroring along a plane. So let's go back to the first extrusion. And we have extruding one direction, the other direction, or both directions. So we're going to change that to mirroring on both directions. So now you see we have a default plane right down the middle. Selecting the mirror command, and then selecting the mirror plane, I have two walls. Now I need to join the two walls with the mounting surface. Starting a sketch, and then F7 to actually see the sketch through the rest of the part. We'll draw a line from one end to the projected line of the base, and now we need to dimension that. Selecting the two lines, and then going to my parameters, we select mount. Exiting the sketch and extruding our new mount from one end, changing distance to the to function, rotating around and selecting the other wall, and we have the mount. Now to just make things look nice, we're going to throw in fillets around most of the edges. Once that is all done, we're going to give it a little bit of color. And last, of course, save the file. Now for a more accurate representation, I'm just going to throw a little pigtail on one end just to represent the wires. Rotating around to the far end, I'm going to draw a sketch and just with a simple circle at an approximate diameter. Then extruding that to close to representing the length of the actual strain relief. And last, another sketch on the edge of the strain relief, and we're going to throw in a real quick representation of a wire coming out of the camera. And now we're all done with the camera base, and it is time to assemble the camera. The camera assembly is very simple. I start a new assembly based on my assembly template. Then I place the base into the assembly, and then I place the camera into the assembly. Now all I need to do is, using an insert constraint, is attach the camera to the base, and we're all done, and it is time to get back to the bracket. And now that I have a representation of the camera, it is time to finish the design of the mounting bracket. First, I start a new assembly and place the mounting bracket. Now I place the camera in the new assembly and constrain it to the mounting bracket. Before continuing, I did take a few measurements of where this bracket will be mounted and time to make a few changes. The mounting plate needs to be a bit longer and that clearance hole needs to be a bit larger. But the camera is actually pointed in the wrong direction, so to fix that I'm going to go over to the browser bar, right click on the camera assembly, then go down and select Flexible. Now, as you can see, I can rotate the camera into whatever direction I want. And now it is time to get that mounting base updated with the new dimensions. Now that the mounting base is about where it should be, it's time to look at the flange where the camera is mounted. The length of the flange looks about right, but there's a lot of extra material here that's not needed. So we're going to give this a little contour. And for that, we're going to need to unfold it. Now that it's unfolded, we can start a new sketch and then draw in the contour that we want. Once that is in, we cut it and then refold it. The mounting bracket looks good, but we're going to need a couple of holes in the base so that we can screw it to the frame of the Forerunner. Almost there. For the prototype, I do not want to use the adhesive pad to adhere it to the mounting bracket, so we're going to need a mounting hole in the camera as well as in that flange. I'll be using a number 8 screw to hold the camera to the mounting bracket, so we're going to need holes that are about 0.17 in diameter. Now I need to save the file and then export it to my 3D printer to print the first prototype and see how it looks. Here's actually the second bracket sitting on my 3D printer. The first one broke. The way it's printed, it is very weak, easily broken. I'm hopefully going to be able to pound this thing out of aluminum once I ensure that the dimensions are correct. So there it is on the printer. So I've got one mounted in the Toyota, so let's go take a look. Here is the rear camera mounted up here. You can see the bracket, the little white bracket up in there. And we'll go around and get a look at the other side. Here it is from the inside. Right now it is double-sided taped up to the top. I haven't actually glued it in place or screwed it in place. And it's there just for checking to make sure it's the right distance from the top, and I can get the plastic panel back in place. So now that we're going to get a look and see how it's viewing out the back. Well, looking at it on the phone, it appears as though we've got it set just about right. This is one of the first times I've used it. Clarity looks pretty good. We'll have to zoom in and see if we can read those license plates. But it looks like I've got the height just perfect. Now just wait to see if I can fit in the plastic fascia. And later on we'll get these downloaded and with proper resolution up on the video. Alright, that was my first prototype. It lasted up there for quite a while, but I was unable to get the plastic fascia back up there, and it broke coming off. This was my second prototype. Although I have the camera mounted to it, it broke almost immediately putting it up there as I went to put on the plastic fascia, but it did show that I have the correct dimensions. So there's my aluminum bracket. I have not installed it yet. I added slots here so I can adjust it for best fit. So now it's time to go put it up there, drill some holes. On the back side I've got a couple of pieces of 3M double-sided tape. I'm going to tape it in place, mark the holes for screws on those two slots, get it screwed in place, and we'll see what happens. And this is the conclusion of the design and manufacture of the mounting bracket. I needed to make one more bend before mounting it in the Toyota, which you can see here in the 3D model. The actual mounting of the bracket is shown in the video Installing Rexing Dashcam in 2001 Toyota 4Runner. Be sure to subscribe to be notified of new uploads and hit that notification bell to be informed of future updates.